Okay, seems like we're live here. Hello and welcome to another Nordic APIs LiveCast. I'll be your host, Bill Dorfeld. And basically these curated hour-long webinars are bringing together some of our community's top experts to dig into specific complex topics related to all things APIs. And today we're joined by Daniel Lindau and Isabelle Mauny, and we'll all be diving together into API security best practices and how we can scale that for large enterprises. So we have a great cast, and I think we're all excited to share here. Like I said, we'll be going for an hour, and we have some time in between for question and answer. Today's speakers, we're going to start with Daniel. And Daniel is a solution architect at Curity. Most of his current work is helping companies of all sizes build secure, standard-based SSO solutions. He has a background as an application developer and a broad experience in building solutions with standards such as SAML, SCIM, OAuth 2, and OpenID Connect. Hey, Daniel, thanks for joining us on this.
Hey. Yeah, thanks for having me.
Of course.
I'll make sure my presentation is up.
Awesome. While you're getting that ready, I can introduce Isabelle. That's going to be our second speaker. Isabelle has more than 20 years of experience in the integration fields. She spent most of her career at IBM in various roles, pre-sales, services, product management. She started working on services and APIs more than 10 years ago and introduced in Europe the first XML gateways. For the past 2 years, Isabelle has been the CTO of 42 Crunch, a company dedicated to bring API security to the commodity level. She has spoken at many API-focused conferences, including Nordic APIs, as well as in several WSO2 and IBM conferences. So yeah, hey, Isabelle, thanks for being on with us today.
Hello, thanks for having me. Looking forward to it. Thank you.
Awesome. All right, before we get into Daniel's presentation, I just wanted to give some high-level updates about Nordic APIs, where we're at. Our next event is going to be our yearly Platform Summit conference. We just opened early bird, so these tickets are the cheapest you're going to get it right now. We are also still accepting speakers. Call for speakers is still open. And this year's theme is kind of on the DevOps mindset of continuous API strategy. So kind of looking for a broad range of topics on that. This should be great to dive into. So please consider submitting. If you haven't already, we'd love to hear from you. Best Public API competition is underway now. So we did this last year for the first year, and we had RingCentral come out as the victor. And we're doing the same thing this year. So we just opened nominations in May. We're going to be announcing nominations as we get them and closing them in late August. Then we open polling to our community to get your votes in, and we will be announcing the winner at the Platform Summit on October 23rd. So if you have an API that you really love using, I would definitely consider submitting. So yeah, just a little bit about today's schedule. After this introduction, we're digging into Daniel's presentation on using OAuth to scale API security in the cloud. After his presentation, we'll have a little bit of Q&A time. So if you have a YouTube account, that's super easy. Just add a comment and we'll respond to it. Next up, we'll have Isabelle's presentation on scaling API security requires automation. And then we'll have a Q&A with both parties involved there. And like I said, if you have a question, all you need is a YouTube account to enter in those details. So without further ado, let's dive in with Daniel's presentation.
Well, thank you. Yes, so my name is Daniel. I work with Curity as a solution architect or identity specialist, which means that I work with our customers to create large and secure API platforms. And today I'm going to talk a little bit about how we scale the access control in these types of platforms. And to do that, I'm going to talk to you about claims and scopes and how we use them to express permissions. I'm going to talk about phantom token flow, which I'm talking about before on Nordic APIs, but with a little bit of a twist on how we deploy this in distributed environments. And then about token validation and how we can scale the trust model between OAuth services and APIs or API gateways. But first then, what is permissions and how do we express them? So in an API platform, there are several different types of permissions that are in play. Well, most namely, the OAuth client has permissions to access certain APIs. It can have different permissions when accessing APIs for a specific set of users, like admin users. They should have higher means of getting data from APIs, things like that. So how do we express this in a scalable way, and how do we communicate this? And of course, we do through tokens. Tokens are a very good information bearer for these types of environments. You can have express both attributes about the client and attributes about the users in the same type of information bearer. This is also something that is validatable, and APIs can trust the data that comes through tokens. So let's have a look at how that can look. So as I said, the client has his own set of permissions, which is something that is a contract with the OAuth server, so to speak. In OAuth, there is a parameter called the scope, which is roughly a permission. It's a scope of access. So you can configure a OAuth client to be able to access certain scopes. And then the client can ask the user to be able to access those scopes on the user's behalf. So in this example, we have an OAuth client that is allowed to request the scope list releases and have been granted a token for the user, the resource owner, Daniel. So this is an example of a token for a client. In the same token, we can also express a little bit about Daniel. Can have claims in there that describes what types of groups he's in, what department he's employed at, and things like that. And those two concepts together make up the actual permission of this token. And to enforce this permission, we can do that in layers. So we need to do different types of access control for the client's claims and scopes, and another set of access control based on the user. So in a layered model, we could have something like this, where on the left-hand side, we have a web application trying to access an API that's behind a API gateway of some sort. And the application has been given a token from an OAuth server at the top. This API gateway has a policy in place that says to access this API, the client needs to present a valid token, and it needs to contain the scope list releases, or otherwise I won't let this request through. So this is something we call the coarse-grained access control, the first access control that happens. So it just can filter out tokens that are valid but don't contain the correct scope to access this API. So we don't have to bother the API with this. But if it have all that, the token is valid, we have the correct scope and things like that, we can put a check mark on it. So we pass the first layer. And the second layer we can call the fine-grained access control, which is performed by the API as close to the data as possible. In the API, we can have a policy that's a little bit more in detail. we know a lot more about the request in the API. So we know that this is a GET request, and it's going to do a query in a database, and it's going to list a bunch of releases, and we can release that data. And to be able to do that, you need to have a client that's allowed to ask for it, and you need to have a user that's part of the developer group, or otherwise you wouldn't be able to list the releases. This policy is a little bit more in detail than the coarse grain that's in the API gateway part of it. And this can be done because this is mostly expressed in code, which is easier to share between APIs. You can make a library out of it and say that I need these types of things. Easier to express and maintain a policy between APIs. The API can use this policy, match it against its token, see that it has the claims it needs, the scopes it needs, validate it, and say, okay, here's your data. And this becomes very scalable because all information needed to make this decision comes through the token. So we don't have to ask for a third party to be able to make our authorization decision. But since we have all these user types of claims in there now, we should, of course, worry about the personal identifiable information. So we can't really give away all this data to any client, because not any client should need it. It's only for the API to be able to make the authorization decision. And the web application shouldn't bother to know that I'm a part of the development group. So that's where the Phantom token flow comes into place. In the Phantom token flow, we have the same players as before: the web application, the OAuth server, the API gateway, and the API. And the Phantom token flow is not a standard itself. It's more of a pattern that uses several standards to make a secure API platform. But as I said, the web application shouldn't have any data that's in this access token. This access token contains data that's only for the API, and thus the web application only gets a token that's a random string, an OPAC token, or sometimes it's called the reference token. It only references data at the OAuth server. It doesn't hold any data itself. So an attacker or this web application can hammer on this token for as long as it likes. It won't find any data. It just is a reference to it, and it can be used as an access token. So this access token is then sent for the API to be able to request this data, the list releases API. And since this token doesn't contain any data, the API gateway won't know anything about it, so we can't make a coarse-grained authorization decision. And even if it led it through to the API wouldn't know anything about it either. So the API gateway terminates this request and asks the OAuth server, is this token valid? The OAuth server responds and says, well, it's valid, and this is the data that comes with it. And this is expressed through a JSON web token. It's the same token, but in a different format. So like the first token we said was the reference token, this is the value token. And that is a JSON document that is signed with a private key of the OAuth server. And this is a token that then is passed back to the API. The API can then validate the signature of the token, see that it comes from a trusted source, use its policy to see if it's allowed to lead the data back to the client. So in summary, we have the web application on the internet side, which where we don't send any information on the token, just that it is a token. And on the right-hand side, or inside the API gateway at least, we have all the information from the access token available for the API, so we can make the authorization decision. And to make it also a little bit more performant, we can add a cache in the API gateway, which can cache the token for the duration of this token. So we only need to do the exchange once. So I slurred past that a little bit, but the API now needs to validate this token. So how do we do that? And this is the value token, the JOT. It is clear text, even though it doesn't really look like it. The pink part here is the header of the token. The green part is the payload, and the black part is the signature. The first two parts, the header and the payload, are JSON documents that are base64 encoded and concatenated with a dot, and the signature is just binary data, that is the signature. So if we look at the header of the token, it contains metadata about the token and how it was signed. So in this case, it was signed with a key that starts with 155, and it was signed using an algorithm that is RSA SHA-256. An API that receives this token should look at the key ID field and see 155. Okay, do I have a key that's called that? The API can call the OAuth server on the discovery endpoint of the OAuth server to collect the keys that it's using. So usually on startup, you make that call once, you have the key and you cache them, and you match this key ID against this cache. So if it is in there, the key ID with 155, then we can use that key to validate the token and then perform our policy. But on the next request, there comes another token with a key ID that's different from the one I used before. And this key ID is not in my cache. That could mean two things. Either the OAuth server has rolled their keys, and we need to make a new request to collect the keys. So we do that, we collect the keys again, and we see, do I have a key ID with 952? Then I can verify the token using that. But if the response from the OAuth server comes in and doesn't have this key ID, that means this token is from an untrusted source, and we should disregard both of the token and the request. So in a cloud environment, where we have environments that can maintain a state, like Docker containers or Kubernetes or even virtual machines or things like that, we have the possibility to fetch all these keys on startup of the service and cache them locally and update them whenever we see new key IDs. So this works perfectly there. But in the case of Lambda functions, where we're supposed to be completely stateless, we don't have that way of caching keys. And that would mean that every time we see a token, we get a new key ID, and we need to fetch the keys before we can validate the token. And now we have a lot of overhead in HTTP requests and before we can validate tokens. And that we can't have, of course, so we must do something else here. And I propose that we use something similar to the browser model that we do today. So all browsers today have a trust store of several certificate authorities that comes with the distribution of your browser. So I say we do something similar, and we create one CA certificate for our domain, saying that this is the issuer of all OAuth token signing keys. And we distribute it with the code, and we allow the OAuth server to have a certificate that comes from that CA and can sign tokens. So that will mean that a token that comes in next time won't have this key ID. It will only have a X5C, which means X509 certificate, and it will contain the entire certificate that was used to sign this token. So the API can then extract that string, validate the certificate, see that it comes from the CA that I trust, that is distributed with my code. And then if it matches, then I validate the token using that certificate. So now we have a trust model in place that is stateless, and we can trust all token that comes to us based on the certificate used to sign the key, sign the token. Yes. So one more thing on the Phantom token flow. In my previous picture, I had the API gateway as a single entity, and that makes the architecture pretty simple because we have the same point of entry, and we can easily cache tokens, and we won't lose so many round trips for doing the exchange of tokens and things like that. But if we consider this a cloud native environment, it's probably not like that. It's probably multiple gateways, either deployed in the same cloud, or it can be distributed across regions, which will make the caching a lot harder. We will have to make several calls, and if we're unlucky, we can have a new gateway for each call, and that would mean that we never gain we don't gain anything from the cache. Since the access token is fairly short-lived, we might hit a new one for each call. So when we're in this environment, we could allow the OAuth server to warm up the cache for us, to push out the token pair, both the reference token and the value token, out to the caches of these gateways, either to one in each of them, or if your gateway supports it, some shared cache. All depending on what product you use, of course. So lastly, just a few notes that we learned from deploying OAuth servers in Kubernetes clusters at our customers, that OAuth runtime server nodes, when deploying them, they have to be completely stateless. Since we want to be able to spin up and down services based on the current load, you can't have a state in your runtime, because, well, you will lose requests. You will have errors for your users that might be hard to explain for them. You will have to have the possibility to connect to any type of CloudDB, since you don't want to tie to a specific cloud provider. Next year, you might want to switch to something else, and you don't want to have to build all new plugins just because you're switching the platform. Asymmetric clusters, well, that's something in OAuth. There are multiple types of endpoints, and some of them are authenticated and some are not. For instance, the endpoint that you fetch the public keys from the OAuth server is not an authenticated one. So those will produce different types of loads. So if we're able to scale them differently, we may gain performance, and if we gain performance, then we have to pay less for them if we pay by the hour. So it might make us some money. And to be able to do these types of things, you will have to have an independent startup and shutdown of your containers or runtime nodes. And since pulling down an admin node shouldn't harm the rest of your cluster, and pulling one up shouldn't affect the current running state. Yeah, and with that, thank you for this time, and I just want to say, check out OAuth.tools. It's a new OAuth and OpenID Connect playground that we built a few months back, and we're extremely proud of it. So please check it out. Thank you.
All right, thank you, Daniel. Yeah, and we'll actually be covering OAuth.tools soon on the blog, hopefully waiting on a writer for that coverage. But yeah, excited to dig into that. So yeah, great. You covered a lot, access control in an API platform, the Phantom token flow, token validation, and scaling trust. I don't see any questions from our participants quite yet. I think it's a little early on, but perhaps to kind of open the floor, from your experience, what do you see as the most common problem companies have when they try to scale their security? You have anything in mind?
Yeah, the first thing, the biggest problem we've seen is those Lambda functions.
Mm-hmm.
We've seen this with several different customers, that they have this problem, and they've implemented the standard OAuth flow and validating tokens that are incoming, and they got very poor performance since they had the overhead of fetching the keys at all times. So they started to compile in their public keys, which now meant that they can't rotate keys anymore. So they have to use this key all the time. And that's why we kind of came up with this browser pattern that you're able to rotate keys at a server level, and you still don't have to call an OAuth server to get your keys at all times.
Gotcha. And is this browser process limited to one vendor, or is this kind of a more open process anyone could try?
This is this is a standard-based model, so anyone with a server that can handle it can do it. And the model comes from an idea of browsers, but it's not limited to browsers. This is something used anywhere.
Excellent. Okay, cool. Well, I'm sure we'll have some more thoughts to contribute later on in the session here, but let's keep the schedule and jump over to Isabelle's presentation. So I'll stop my screen share and hand things to you then.
Thank you.
Yeah, thanks for presenting.
All right, well, thank you very much. And yeah, I'm going to take a bit of a different approach on the problem here and talking about a completely different aspect of API security in terms of the development and all the tasks that you have to do at large, and authentication authorization is one part of it that Daniel explained. And I just wanted to show you to start with, this is just API bridges for this month in June that we curate on APIsecurity.io. It's a good overview of the type of problems that we have with APIs today and how critical security is. And those three problems you see there kind of really illustrate the type of issue that we have. The first one is something quite typical, this Venmo problem. Venmo is part of PayPal. And they have this API that they thought would be used only from the application. It's supposed to be used only from the mobile application, except it's really public and it's only protected by basic rate limiting. And the way you can see publicly, money exchange is what this application does. So if you want to, you invite somebody for dinner and you want to pay them for it, you can use that application to basically pay them. And this transaction, unless you configure the application properly, is actually public. And you can just do a quick API call and you will see that information. So all this information about every single transaction is now exposed to the public. And it's still working. I've tried it a few hours ago before doing this presentation, and it's still working. So typical issue of security by obscurity and thinking that this is not going to be called and seen because it's not exposed publicly, but it is public. Other typical problem, validation of information, and here we have two examples. One where we're basically allowing anybody to call an API because the core setup is not done properly. So that opens a command injection here in NVIDIA product. And another one, and just to introduce this is not only a logical problem, it's also an IoT problem, because many IoT devices are driven through APIs, and their API vulnerabilities actually also are a huge problem. And here, very typical problem again, an authorization header where we haven't done proper validation here on the data flowing through that authorization header. So somebody sent a large amount of data, causing some memory corruption problems, overflow, and enabling some brute force problems. So just to an highlight of the type of issues, and this is only from just this month, and there is much more on that site you can have a look and learn from. So why is this happening? Because we know all those problems, and why is this still happening? And the reason this is still happening is simply because, there are humans, and there are humans behind all of this were developers, all those APIs and applications. And, this is not a finger-pointing game. I don't want to finger-point at developers for doing bad things there at all, not at all, but simply saying that it's a complicated, world. API security is not easy, and it's very easy to actually do something that's going to be exploitable later. It's not like developers want to introduce problems, obviously, but simply by honest mistake, that's what they do. And that's why it's going to be so important to see after to, always look at what the current state of security for my APIs are in an automated fashion, right? And the other thing that happens is the developers are really rewarded to actually implement application and implement them as fast as possible and running faster, to get things delivered. And we have security trying to secure all of this was running a bit behind here, and also usually is involved very late in the entire life cycle of the APIs. And all of this is creating various type of problems. So how do we address this? And really, what we have to do if we want to address the problem at large is starting to look at API security very early in the life cycle of the APIs and applications, right? So you may have heard of this as shift left. So shift left in sense of not look only at at testing maybe phase. Let's see if there are any security problems, or even some people who are doing pen testing and this kind of testing say, well, I'm being called when the thing is already in production. It's so much I can do once it's already in production to actually address all the security problems. And one thing you have to keep in mind is that obviously—
Hey, Isabelle, I hate to do this. I'm so sorry, but
Yeah.
we got some comments from our users that your slides aren't coming through. So if we can just try to make a quick adjustment.
Sure.
And we have some of our support on the line. Hopefully we should be able to fix it.
You can't see my screen. Can you see that? Is that working?
Just a second. I mean, it's looking good in my control room, but I'm not sure if it's coming up on YouTube. Still not showing we're getting.
Can people confirm it works?
Yeah, nothing on their end. Okay, let's just keep on going. And to everyone watching, we're going to be linking to these slides after the presentation.
Okay,
So, yeah.
I don't understand what the—
Yeah, sorry about that. I don't know why.
problem is.
Fine for both of us. Yeah.
It's working for you guys. Okay. Anyway, let's not lose more time here.
Yeah, of course.
Well, I'll pass the presentation after that. Sorry about that. But the idea then, so keep in mind basically that the later you discover problems in the life cycle, and the more costly it's going to be to fix those problems, right? So think of it as if this is architecture and you're building a house, the requirements phase is basically doing the blueprints, right? When you're on the paper and using blueprints, changing things is easy. The minute you start putting bricks and creating the house and laying out the rooms and the walls are done, then making any changes to that architecture is extremely complicated, and it's going to cost much more, if possible. In development of APIs, you have exactly the same problem, which is the earlier you actually consider security, the less expensive it's going to be to address the issues that you find. Okay, so what are the guidelines in terms of shitting left? What should I do, right? And first of all, this is really a teamwork, right? It is something where the business, the security, the development, the operation people, everybody has to collaborate towards API security, because everybody has a piece of the story and the solution here. The business people, the developers, they know what APIs have to be developed. They know, how those APIs are going to be used. Security has the knowledge of, what has to be done in terms of protecting them. What are the core rules that have to be applied, like Daniel explained before, what are the security principles that I have to follow? And operations is a huge play in here, especially again in the light of what Daniel was saying on all the new deployment models such as Kubernetes and cloud-based development and Lambda and serverless, etc. This is bringing all new type of problems on the table, and everybody has to work together to actually address those. And so basically, the first thing you have to do is, we're at requirement and design phase here. The first thing you have to do is to know your APIs. You cannot protect something that you don't know. So you will have to understand, what are those APIs we're writing? Which data is it manipulating? How sensitive is that data? Who is going to access that information? And this is going to allow you to do, threat modeling, if you want, and understand what are the risks attached to those APIs. And again, it's not the same to protect, say, maybe you're the weather channel and you're creating an API that manipulates the weather data, which I think we can all agree on is not sensitive information. But if you are a fintech and manipulating payments and account information across multiple banks for your customers, then things are very different. So what we see when we work with our customers on this is, basically, you're going to see emerging 2, 3, 4 different profiles of APIs across your organizations. And then you will have to adapt the security levels across those different APIs. Those different profiles, of APIs. Okay. So first of all, know what you have to protect, and know the risk that you're associated to exposing data and information and operations on that data. And then once you have done that, in terms of implementation, so first rule of all, I said this also in a conference at Nordic API some time ago, zero trust, like you don't trust anything coming your way. What does that mean really? What that means is, if there is zero trust, it means everything that comes your way, you have to validate. So all this data that comes your way, the tokens that Daniel was talking about, it doesn't matter if this is a microservices architecture and this is east-west traffic and this data is coming from the microservices next to you, or if it comes from a mobile application which is external. Doesn't matter. The same principles apply, simply because if you take it this way, then there's no exception. If you start creating exceptions to this, you're going to start creating problems. So it's easier to say zero trust. Whatever I receive, I have to validate and make sure this is something I'm expecting, in the line of what Daniel was saying on validating a JWT and knowing if I trust the certificate or the key ID that has been used to actually sign that JSON web token, right? Second, don't try to reinvent the wheel. What I mean by that is, there are tons of products, of libraries on the market. There are people who are specialized in writing those. I have the knowledge for doing it. And I know sometimes we think, we can do it better. We're developers, I'm sure I can do it better for my company because my company is special and I can invent something, that was going to work better for my company. But in the long run, this simply, doesn't work, right? In the long run, what's going to happen, you have something to maintain. The standards are going to evolve. You're not going to be, you don't have that community that actually validates that library or deployment or product that you have made be created. You're the only one using it, basically. So don't do that. Just make sure that you find something that fits your needs, and maybe talk to those people if there are things you want that are specific for you. But starting from scratch and inventing something new is usually not a right approach. Then protect sensitive data. What does that mean? That means that you're manipulating sensitive data. What that means is your own data, like something that would go in a database, your API keys, your secrets, to create those JSON tokens we were talking about, or to encrypt and sign payloads. All of this is sensitive data. And we have to be extremely careful in terms of making sure that that information is in safe places, that it's maybe encrypted at rest. Again, it depends on that sensitivity we were talking about that threat model you have done. Be very careful about GitHub and repositories, and making sure you don't spread API keys. This is like the new repository for keys is actually GitHub, GitLab, and this type of tools right now, because people just don't realize that this sensitive information is up there. So as you manipulate this data, be very careful. And then also be very careful and what are the potential problems here? Error handling, maybe you're not properly capturing some exceptions within your API, you don't react well to it, and you're returning some information to the caller that they should never see. It can be exploited to actually, find some vulnerability in your code and your implementation. And very careful as well when you do logging of information, that you don't log sensitive data in your logs, because again, this is something can be seen by others. Even within the company, this is still sensitive data, also logs into POI problems as well, making sure that you don't log those and they're properly protected, right? So there's a lot to say behind this. We have only 20 minutes here, but if you follow those principles and dig into those, you're going to find a lot of information on details of what you can do in here, but keep those principles in mind when you develop. So that's the development phase. Now, in terms of testing, so something which is very interesting, I love that picture of, you assume you have created something, you expect users to do something with it, but in the end, they're using the system in a complete different way than what you thought would actually be used. And so you really have to think and about what users are going to do that you never thought about, right? And in order to detect all those problems, so we're usually pretty good at testing our APIs and at testing what I call the happy path, right? And doing positive testing in terms of I have positive use cases, and if they don't work, then my test fails, right? So we have to start writing negative use cases. So we have to start testing, like I call that the hacky path, which is bombarding your API with tons of information and data that you are not expecting, calls that you're not expecting, and see how your system reacts. And do that automatically as early as possible. If you're doing an API first, API contract first type development, where you start from the API interface and then do the implementation, put that in place straight from the beginning, so that you can catch very early in the development, you can catch very early those problems that are added to the code as you go and implement your API. So just, send a lot of bad data to the system and see how it reacts. And also make sure that the information that you're using, so the code, the libraries, your Docker images, the setup of your system, all of that is properly, so there's multiple levels here. Let's talk about libraries, because that's a big problem. So a lot of environments, not to name one, Node.js, for example, is relying on an ecosystem where you go and install third-party libraries, and you have to make sure of two things here. First of all, that this library is not stale, so that there has been a new version of it, and that new version doesn't have the vulnerability that the current version you're using actually has. So you must, again, the only way you can do this is through automatic analysis. There's tons of tools out there that allow you to analyze your third-party dependencies and tell you, hey, you're using version 2.1, watch out, this is this vulnerability in 2.1, but there's a 2.3 which is available that you should use, where that problem has been corrected. So that's at the libraries level. You would have the same problem in Docker images if you're using a base image, whatever it was, something you took from Docker Hub, or an OS base that you are using that, again, has some vulnerabilities. There are tons of registries now where when you upload a new Docker image, it will automatically analyze the image and tell you if it has vulnerabilities. So all these pieces of code and things that you're using, you need to continuously test whether they're at the latest level and you're not bringing on board some vulnerabilities that you don't even have written yourself. You're just coming with whatever you're actually reusing. You can do that as well through, for your own code, do static analysis, dynamic analysis of your code, making sure that you have not introduced in your code, wherever it is, some problems. And again, discover that as early as possible as you push your code into your CI/CD pipeline, get this information as early as possible and fix it as early as possible. And what I mean by transport setting is also making sure that your TLS levels 1.2 is the minimum you're using, that you have the proper ciphers in place when you're using TLS and SSL, and you have tools again that will just point to your API endpoints and give you a full report automatically of, hey, watch out, you're using this really old SSL library and you're using TLS 1.1, which has this and this problems in it. So all of that you really have to automate. And the reason you have to automate all of that is what we see at customers, and people now have hundreds, thousands of APIs. There is no way you're going to do any of this manually. So if you want to do this at scale, the only way to actually do it properly is to automate that entire process of validating the code, validating the libraries, validating the image, talking and invoking and touch production. Okay, do that first, and then once you have done that and you found all those problems through an automatic way, then you can go into a manual way and do, depending again on the risk, do pen testing, do a bug bounty program where you'll have people coming on board again as early as possible. Don't wait until you're in production to actually do that. There's not much they can do then, but as soon as you have something they can play with and they can analyze, then bring those people on board. And there is nothing like a human and its intelligence to find, this more advanced problems in your code and in your APIs. Okay, so hack yourself and find all those problems. And finally, that's the testing part. Now we're deploying all this. So the good old principles with APIs and applications are still, the same, which are defense and depth, right? So what we want to do is we want to have multiple layers of defense. First, I have to go maybe through a CDN that does like DDoS protection, and I will go into a web application firewall or an API firewall that will analyze the web and the API traffic. Then I will have validation at the API level itself, so that you don't have a single wall of protection on your system, but you have multiple layers that you have to go through until you get to the proper, until you get to the API itself. And also, go back to the good old principles of multi-layered, model view controller. That's what I learned when I started working. We had this like very well-defined framework for developing, which was MVC, where you would have a front layer that will do the interface with the front end and with the UI. Then you'll have a processing layer, then you would have a data layer, right? So respect those layers, put the proper separation between those layers. So if one layer gets compromised, it doesn't get to the next one. Again, so in terms of deployment at scale, again, put those principles in place so you can have, hundreds of APIs in there, but have all the proper layers to actually validate information. So put those security zones in place. And something also very important, and as we go to the cloud and more people are using the cloud, be very careful of the privileges that users have as a developer, as for deploying, etc., when they work with the cloud. It is very easy to just give very large permissions to people and then have them play around because it's easier to configure, but it's always something you're going to pay in the long run. Make sure that in your applications, you validate also that the person who's doing the invocation of your API has the right privileges to do the operation they have to, right? So keep that principle in mind of, okay, I'm receiving that call. Do I know that user? Do they have the authorization to do what they want to do? Are they allowed to access that piece of data that they want to access? This is, for example, I'm just opening a window here on this. is a very big problem. Number one problem right now on API security is IDOR, or broken access control problems, where, for example, you have a URL and you say / account number /123, and I have a proper token as Isabelle, and I'm allowed to access account 123. What if I replace 123 by 125? Who owns 125? Not me. That's not my account. But I have a valid token, so I can actually go and access the API itself. But where do you validate that I can actually access 125, right? On those UIDs as well, and the URL, that's one aspect of the problem. But the second aspect of the problem is this fine-grained authorization also that Daniel was talking about. So making sure that you have all the right privileges to access the data, and in terms of deployment, making sure that the least privilege principles actually apply. And finally, you can't fix what you don't know, so you need to monitor all your systems, right? You need to monitor you have all those potential problems. You need to monitor that there are problems that have been discovered, maybe in the testing phase, and you have to have regression tests for each of those to make sure they don't pop up again. And then from a runtime perspective, you want to analyze the runtime behavior across all your APIs. So again, if you have 100,000 of them, there's no way you can look at them one by one, where you need a system that looks at them across the board, finds out those misbehaviors that are abnormal based on the normal behavior, and raise alerts so you know very quickly if something is going on inside your system. So as a call to action, to finish on this, I would say, first of all, introduce API security as early as possible in the life cycle. So if you can start with design and requirements, please do it. It's going to pay very much in the long run, even if it seems like it takes a bit of time and it's extra work at that time. It's really going to pay in the long run. Take the time to actually teach and learn security across all the teams who are involved. Automate as much as you can, as much as humanly possible, across the entire life cycle, so you can discover all those problems very early on, then learn from this and rinse and do again. All right. And with that, just thank you for your attention. I'm very sorry about this problem with the
Isabelle, thank you. And it looks like your audio was a little strange for that last part, but yeah, so happy to have you on board, and no worries about the slides. It's like we're having a podcast, right? We'll
yeah,
try and
sorry.
put them later.
You don't understand what happened here. I'm very sorry.
No worries. Yeah, but in general, an excellent overview of the benefits for automating security, putting the proper separation between your layers and learning how to deploy at scale. I think that the comment you said about just having zero trust, it's sad but true in light of all these breaches that you mentioned earlier on. I think one of our participants had that in mind. They were saying, how does the imperative of zero trust square with the different profiles you've defined for your APIs? And they were giving examples for weather APIs versus fintech APIs. So I think they're tuning into how does the different use case affect the imperative of zero trust?
So there's two levels, right? There's zero trust. The main imperative, I would say, is making sure that the data and the information that flows through your APIs is actually always validated. So you don't trust to say, oh, I'm receiving this token from, this API that sits right next to me, so I'm going to trust it because, hey, it's just got generated there. So and it's internal, so I'm just going to trust it. And basically making sure you don't do that. You just test all the time and validate all the time, independently from where this data is coming from. And it can be even, I'm going to push that even further. A lot of people are using external API. And if you're doing that and you're calling a third-party API, I will still validate, making sure that the data that comes back is actually what I'm actually expecting in terms of its schema, etc. Just to make sure that if those guys got compromised, I'm not actually capturing and consuming that information without even, trusting that it's actually okay. In terms of teams and people, right? So that goes back, I think, more to this list privilege principle I was talking about. It's just to make sure you just have people have the right amount of information for their job, right? I'm sorry about the wind here, closing the windows. So that they have the developers basically have the right information for doing their job in terms of accessing the data, etc. But if they don't have, for example, the user ID and password to connect to whatever, the production database, right? So that they don't test against that. So you want to segment the production data from test information. So you don't want them to access to this type of stuff. Only the ops people can access that, right? So this is the principle is going to push and say, okay, you just have access to the information to which you need to have access. I'm not trusting you to have access to other stuff. That's just because you're an employee within the company. Sorry, you just see what you have to see. And then from a development perspective, just do all this validation. I hope that addressed the question.
Yeah, no, I think it does. Perhaps Daniel would chime in here. What are your thoughts on this imperative of zero trust and perhaps in these different environments?
Yeah, so well, I agree with Isabelle. The zero trust is the model that you have to build from, starting from there. And that's also part of what I was presenting with the fine-grained and coarse-grained access control. A few years back, it was pretty common to put in an API gateway there and have a token between the client and the API gateway. And then after the API gateway, it was just open because we implemented OAuth in the front end and now we're secure. And we know that the API gateway is only talk to our trusted internal APIs, then nothing can go wrong, right? And then they have a employee that's not entirely happy with the boss or something like that, or orders a bunch of stuff for them. So we still, even if we're in a trusted environment that is our own internal network, we still need to validate things. We need to do the access control based on the caller of the API, and we need to validate that it comes from a trusted source. Right. I know that me and Isabelle joked a little bit about that on the platform summit, where I said, don't trust anyone but your OAuth server, but you should also only trust the OAuth server because you can validate that the traffic is coming from there. You're using TLS to know that the keys are coming from the right place, and the keys you're using proves that the data you're processing right now comes from the right place. So definitely zero trust.
Indeed.
Awesome. Well, I think that was our main question that we wanted to address with this livecast. And it looks like we're nearly at the hour mark here. So yeah, thank you, Daniel and Isabelle, for presenting and answering little questions here. I think I'm just going to do a little sign off here, and then we'll leave it at that. But I hope to have you both back in Nordic APIs, for the Platform Summit, or maybe in Austin, Isabelle, if you can make it out to the States, perhaps.
Would love to, absolutely.
Awesome. Well, yeah, thank you so much. And we'll try to fill in the slides on the video, hopefully later on. So let me just do my sign off here. All right, are we seeing that? Okay. So yeah, thank you. Nordic APIs is sponsored by Curity, and they're part of the team helping put on events for Nordic APIs. And if you'd like to keep following Nordic APIs, you can check us out at Twitter at Nordic APIs. And also we have a Slack channel, slack.nordicapis.com. Our next conference, like I mentioned, is the 2019 Platform Summit. And this will be held in Stockholm from October 21st through the 23rd. And early bird tickets are available for that. Hope to see you there. We're trying to do a lot more of these online webinars. while we work out the kinks, because we're a little new to this still. If you'd like to participate, contact us at info@nordicapis.com. We also have a lot going on outside of the webinars. In addition to the events, we're running this blog, and you can find that at nordicapis.com/blog. We also have a lot of ebooks that we've put out, all related to API strategy. Our blog is pretty open to the general public. We love to get contributions from API practitioners who are taking this knowledge, applying it to their own environments, and then kind of giving back to the community. So our blog is open for submissions as long as they're vendor neutral and more in the thought leadership kind of style. So if you'd like to, you can always contact me about that. Yeah, consider signing up for the Nordic APIs newsletter. I organize a bi-weekly digest of API insights that is supported by a great writing team here at Nordic APIs. And I think that's all I have for you right now. Thank you for joining this live cast, and I hope you stay tuned for more in the future. All right, thank you.